how Earth would look like from far across the universe. When you're looking at the stars in the night sky, you're looking back into the past. Yes, you heard that correctly. When you are viewing anything in the universe, you're looking back in time. This is because we can only perceive objects in the universe as they were when the light from them was most recently emitted and arrived at our eyes and sensors. Because of this, light from objects far away from us can take millions of years to reach us. That is true here on Earth and all throughout the universe. So if that's the case, what about a distant observer on a planet observing us? What would he be able to see? Will he be able to see humanity or dinosaurs? Let's talk about what Earth would look like right now from far across the universe. How do our eyes work? How are we able to see everything around us? Surely there might be physics involved behind that, and it's quite simple. Light is emitted or reflected from a particular object, and when that light hits our eyes, we're able to perceive an image of the object. If no light is falling on our eyes, we see the absence of light, which is simply darkness. The speed of light is the fastest thing in the universe, but still it's not fast enough to cover the vast distances of our universe. In fact, our universe is so vast that even with the speed of light, anything will take 93 billion years to travel from one end to the other. You are only viewing an object as it was a specific length of time ago. At the moment, the now arriving light was emitted from the object you are watching. The image of Andromeda that you see is 2.5 million years old, because light took 2.5 million years to reach us. Similarly, the image of the sun that you saw in the afternoon today was not its real image. In fact, it was 8 minutes old. It's a big realization. Every observer in the universe will perceive right now as the same instant in time relative to the Big Bang, 13.8 billion years after that creation event, until and unless they haven't spent a significant amount of traveling close to the speed of light, or in an extraordinarily large gravitational field such as just outside a black hole's event horizon. The speed of light is fast enough for local objects that the time delay between source and observer may be ignored in most circumstances. However, the more out we gaze, the further back in time we see, closer to the instant of the Big Bang. This would mean that when a distant observer looks at Earth, they are seeing an old image of it, i.e. how the Earth looked in the past. Let's go on a journey as an observer to different points in space and observe our planet Earth and understand what it would look like. And let's assume we have a powerful enough telescope to easily make observations of Earth from these distant places. Number 5. From the most distant object known to humans, galaxy GNZ11. First discovered in 2015, GNZ11 is a highly red-shifted galaxy and is the farthest galaxy ever known in the observable universe. At a distance of 32 billion light-years from Earth, the galaxy was recently observed as it existed 13.4 billion years ago, 400 million years just after the Big Bang. In case you are wondering how it is at such a large distance from us if the universe is only 13.8 billion years old, well, the universe is expanding, and that too at a speed faster than light. If we point our telescope towards Earth, or at least try to look in its direction, we would see a young Milky Way galaxy forming. The dark matter would be pulling billions of stars, gases, and dust together into a newly formed Milky Way. The Earth or the solar system wouldn't even exist because its formation started only 5 billion years ago. What we would be able to see right now is the image of the Milky Way 13.4 billion years old. The universe would still be young and relatively hot as compared to today. Hydrogen and helium would be dominating this newly formed universe, and its stars, which would eventually lead to the formation of further heavier elements in the core of these stars and would lay down the precedent for our formation, because we all know that we are literally stardust. Number 4. From the Andromeda Galaxy, our neighbor. The Andromeda Galaxy, also known as Messier 31, is the nearest galaxy to our Milky Way. It's located at approximately 2.5 million light-years, or 765 kiloparsecs away from Earth. If we try to observe Earth from the Andromeda Galaxy, we will be able to see the image of the Earth 2.5 million years old. That is what our planet looked like 2.5 million years ago. Someone from Andromeda would be able to see the very beginning of the Paleolithic era, when our ancestors first began utilizing Stone Age tools. There would be fires at night ignited by our hominid ancestors, the earliest members of the species Homo, but prior to the advent of Homo habilis. In addition to flames generated by heat, lightning strikes, and volcanic eruptions. For almost 1 million years, our ancestors lived only on the African continent alongside members of the species Australopithecus, the only area where these distinctive night fires would occur. Number 3. From the Large Magellanic Cloud, the closest intact galaxy to us. Andromeda is definitely the closest galaxy to us, but the closest intact galaxy to us is the Large Magellanic Cloud, or LMC. At a distance of 163,000 light-years or 50 kiloparsecs, the LMC is a satellite dwarf galaxy of the Milky Way. It contains about 10 billion stars and spans about 32,000 light-years across. If we are in this galaxy, the Milky Way would look vast and massive and would take up a big part of our night sky. An observer from this galaxy would see Earth as it looked 163,000 years ago. During this time, Homo sapiens had already evolved. They were also joined by our direct ancestors, that is, Neanderthals, Denisovians, and maybe the last of Homo erectus. Earth would be rich in indications of life with a flourishing flora and fauna. Earth would have been in a long-duration ice age for approximately 80,000 years, the penultimate ice age before the birth of human civilization. Number 2. From the brightest star in the night sky, Sirius. Our night sky is filled with thousands of stars, and the brightest of them is Sirius. It is located 8.6 light-years away from us and is a binary star system. If we made observations from the Sirius star system, Earth would appear as it did back in 2014, simply because light from Earth would take 8.6 years to reach Sirius. Barack Obama is the current president of the United States. Scotland is poised to vote on whether to stay in the United Kingdom. Viktor Yanukovych, Ukraine's pro-Russian president, has just resigned and departed the country. ISIS is posing a growing threat in Iraq and Syria, and the first Ebola cases have been reported in Liberia, Guinea, and Sierra Leone. During the winter, the atmospheric carbon dioxide level drops below 400 parts per million, although temporarily. A suitably sophisticated Syrian might identify our climate and weather patterns, decipher our transmissions, and assess our degree of technical sophistication. If they chose to reply to our presence, two-way contact might be established in about 17 years. Number 1. From the most distant man-made object, the Voyager 1 probe. Voyager 1 is officially the most distant man-made object. It is currently at a distance of 158 astronomical units, which corresponds to 14.7 billion miles or 23.5 billion kilometers. It took 45 years to arrive at its current location, which is beyond our solar system's termination shock after it was launched in 1977. It's one of just 5 spacecraft currently fleeing our solar system, and it will remain the most distant for all time until we launch a new mission to catch up with it. And yet, from such a great distance, further than any planet, moon, asteroid, or Kuiper Belt object in our solar system, its perspective of Earth is just 21 hours and 46 minutes old. It sees us as we were just 21 hours and 46 minutes ago. An observer on the moon sees us as we were 1.25 seconds ago. An observer on Jupiter, which is currently at its closest in 59 years, sees us as we were 33 minutes ago. And an observer on Pluto, which is currently 5.1 billion kilometers or 3.2 billion miles away, sees us as we were 4 hours and 44 minutes ago. Observing the Earth from different places in our universe would give us these different views of Earth in different timelines. When someone looks at us from any place in or near our solar system, the period of time they look back in the past is quite short, especially on a cosmic scale. Another way to look at it is that 1 light year is a very, very big distance in comparison to the magnitude of our solar system, a distance that Voyager 1 won't cross for tens of thousands of years. But if an advanced alien civilization tries to observe us from a distance, they won't see Earth as it is now. They would see an old image of it, and unless they are in a 200 light-year radius from Earth, they wouldn't be able to see our technological advances too. So what do you think about observing Earth from different places in the universe? Would you like to go on such a journey or make an observation if possible? Let us know what you think in the comment section below and share the video with your friends.